Traditionally what we do with when we look for soil acidity is measure the 0 to 10 centimetre topsoil, and that's done as a soil core, and that sample will be analysed, and so we get a pH value for that 0 to 10 soil. What we now know is that the acidification doesn't happen evenly through that top 10 centimetres, and it's actually stratified. So the very top centimetre or so can be pH 6, 6.5, but then as you get down to maybe 4 centimetres, you start getting very acid pHs around 4, 4.5. And so when you sample the 0 to 10, you're actually getting an average of whatever the stratification is in pH. And so where we've seen that become a problem is in acid sensitive plants, and some of the grain legumes like faba bean, chickpea, lentils, will get crop failure in a soil that the 0 to 10 said that acidity isn't really a problem. And when we look in more detail, we actually find that we have these acidic layers in the soil just underneath the surface. So we call them subsurface acidic layers, and they limit the production, but their presence is hidden by the way we're sampling. And so what we're recommending is, if you're going to grow an acid sensitive crop, we need to be looking at that 0 to 10 centimetres in other increments, a 0 to 5 and a 5 to 10. And that additional effort and cost, you actually get that paid back, because if you can identify that you've got a subsurface acidity problem, then you can choose maybe not to grow that sensitive crop, or have a liming activity where you actually incorporate lime through that zone to get rid of the acid layer. But in agriculture, we can actually create those stratified layers, maybe by liming without incorporation, because you're just adding lime to the surface without mixing, so the alkali is actually at the top. And that, in a way, that's the worst case scenario of a lime addition, because you spent the money, but you're not getting any of the benefit because it's sitting at the surface instead of being down where the acidity really is. And then the other way those acid layers are formed are by ammonium-based fertilisers placed at that layer. And that's a problem, but it's also potentially we have a solution there, because if it's formed by a placement of an acidifying nitrogen-based fertiliser, then perhaps we can look at putting the lime or the ameliorant in that same layer. If you've got a 0 to 10 soil core, you can just get a piece of wood that's 5 centimetres thick with a hole in it that you can put your core through. So when you put that in the ground, you're actually only taking the 0 to 5. You take that sample out, remove the piece of wood, put your core back in the same hole, and the next bit that comes out is the 5 to 10 centimetre segment. So it's no new extra gear, but you're just creating a 5 centimetre thick collet that stops the whole core getting taken in one go. If you apply lime and you can incorporate, you're definitely better off doing that to get the lime where the acid is. If incorporation isn't going to happen, then surface application is all you have of lime, is all you've got. And it's important that the rates of lime that are added are high enough to get the pH up to a point that alkali starts moving. And from the research that we've done so far in limited trials, the recommendation would be to keep that pH up and over 5.5 in calcium chloride to maximise the opportunity for alkali movement downwards. And some work done through DPI and Charles University has shown that organic matter with that lime can actually enhance the rate of alkali movement with depth when you don't incorporate.